Hello everyone, welcome to Amazon Web Services Machine Learning Operations with AWS Masterclass. And this is day 19 of this Machine Learning Operations with AWS, and I welcome you all on behalf of pantechelearning. So in today's class, we'll be discussing about deep learning. So we have discussed about all the base of machine learning and their parts. So a subset of machine learning is deep learning, where we'll be seeing about what it is, how it works. Okay, and in today's class we'll see what are the basic terms you need to know in deep learning, how comparative it works apart from machine learning. And in tomorrow's class we are going to see about CNN and a project which is project 4, dog versus cat identification or classification project using deep learning. So that will be our today's and next class agenda. So starting with deep learning, so as we all know, deep learning is a subset of machine learning, and they use some kind of neural network. So what it is? In machine learning, what we'll be doing is we have algorithms, right? We have algorithms and we'll be using that for prediction. The same thing, the black box, instead of algorithm, we have something known as neural network, where you give something, it will give you the output. Okay, the same, instead of algorithms, here we are using something known as neural networks. So what is this neural networks? These neural networks are a combination of neurons. Okay, we have neurons, and this deep learning or neural network are created to mimic the human brain activity. So in our brain we have neurons, right? So they combine to form a neural network in our brain, and then similarly we are having something known as neurons. So when you see a neural network, you'll be having some images like this where they are interconnected, and these nodes are nothing but neurons, and they'll be interconnected. Okay, and these neurons combine to form a neural network, and this network will do the processing and give you the output. So individually each neuron is doing some work and giving you the output. That is, they are doing it combinedly and giving the entire output. So we'll discuss about that, starting with a neuron. Okay, so this is what a neuron will look like. Here we have a neural network, but when you go inside of a network, and you will be seeing each neurons. Okay, so this is what will happen in a neuron. For example, so this is the architecture of a neuron, where you will be having lot of inputs. Okay, you will be having different inputs, and this inputs is given some weight. For example, whoever it is important, this guy is important, I'll give more weightage. This guy is not that much important, I'll give less weight to him. Likewise, some weights will be added. We'll be discussing about the weight, activation function, etc. deeply in this class. Today's class, like this session, will be elaborately about the maths behind it, how the neural network or neuron work together, all the basic terms about it. Okay, and we'll discuss this elaborately. But for example, you are giving inputs. Imagine these are your for example, you can use it for your CSV files also. These are your rows, x1, x2, row 1, row 2, row 3, and based on the weightage, it will assign some weight and give it to the neuron. So inside this neuron, something known as bias is added. Okay, along with this, a bias, something like a value is added, which is a constant value which is added for everyone, and then it is summed and passed to a function which is called as activation function. So this will do the process. Okay, here we'll be adding everything and giving it to the activation function. This guy will do some process and give you the output, and this is what will happen in all the neurons. So they will be getting the input and passing it to the next layer. And this is what a perceptron is, which means it get the input, assign the weight, okay, do the activation function and give you the output, and they combinedly give the output. It is called as a basic perceptron. It is the base version. And this is what a deep neural network will look like. So you will be having multiple nodes, okay, interconnected, going forward and backward, and finally the outputs. So we have many layers, something known as, when you go and see a neural network, combination of neurons, but if you arrange them, you will be getting an input layer and finally the output layer, and inside of it you have multiple hidden layers which will do the work for you. Okay, and then going into the next one, let us see some intro about neural network. In a neural network, a neuron, okay, is the basic unit that receives input from other neurons or from external data. For example, here the input layer will receive the input from the external network, which means like the data you are passing. But these neurons will be receiving the input from previous neurons, right? So neurons will give it to the neurons, and neurons will give it to the neurons. Some neurons will get it from the outside environment. which is like the data set you are passing, etc. And other neurons from external data process that input and produce an output signal. And how they are doing the output? Some weight is added, one bias, a constant is added, and activation function is added. The same thing. Okay, and which weight, which activation function we'll decide it later on. And this is what a neuron will do: get the input, do this process, give the output, and a combination of them will work together. And the output of one neuron can be connected to the input of another neuron. We have seen, right? From one neuron it will go to another neuron, forming a neural network of interconnected neurons that can learn to recognize patterns in data and make predictions or decisions based on that data. Okay, and a typical artificial neural network, so this, the base version is called as an artificial neural network. It consists of input layer, hidden layers, and output layer. Okay, and they are supported by something known as activation function. We have seen that function, right? Something happening there. And we have something known as loss function and optimizers. So these are for the improvement of the neural network. We'll discuss that later. And this is what the architecture of a neural network will look like. And once again, a neuron will do this process. A neural network will be connected like this, and it will do the same process, and you have the supporting activation functions, loss function, and optimizer. Once again, the layers, when you see it, the input layer receive the input data, and each input is represented by a neuron. And like for example, the number of neurons in the input layer depends on the dimensionality of the input data, and the hidden layers are where the network learns to recognize complex patterns in the input data. So here you won't be giving any patterns. It will try to recognize on its own by passing it through and forward and backward through the hidden layers. And in a hidden layer receives input from the neuron in the previous layer and produce it to the next layer. And you can have multiple hidden layers. That's up to your wish. Your input or the output can increase based on the layers. And the output layer finally produces the final output of the network, which can be prediction or classification or some sort of output, any output. Okay, the output layer produces the final output, which can be a prediction or classification or any type of output. And this is what a single layer neural network will be. You are having an input layer, one hidden layer, and one output layer. It's a single layer because it's having one hidden layer. Okay, and this is what a multi-layer neural network will look like. It may look complex, but it's very simple. If you understand the math behind it, it's just simple things. Okay, just max. So that we have input layer, we have output layer, you have multiple hidden layers. They are interconnected. Okay, one layer is connected with all the layers. That's how it will work. So what happens in a neural network? Once again, if you want to learn about them deeply, so many won't know what is happening there. They'll just create a network and then go with that. You need to have this basic understanding, then only you can decide which is the thing I can choose for my project. And here we are having input, we are having weight. Okay, some weight is applied to the input and given to the neuron, and a bias is added, which is a constant, and the activation function is done. So let us learn about what is weight, what is bias, and what is activation function in depth. Weight, bias, and activation function. I want to clarify once again where it is applied. So the weight is assigned to the inputs. Okay, for x1, x2, some weightage is added. How much weightage it should be getting, that's what the weight will define. And then some bias is added, which is a constant value. So to keep it, like for example, in some places, if the input is 0 in all the place, it will be passing through the activation function, nothing will happen. To avoid that such kind of error, one bias value, which is a constant value added constantly to all the inputs, will be getting added. And some activation function is done, where some kind of max is done, and then some getting output, you will be getting the output, and it is passed through one layer to other. And this is what known as a forward propagation is. Okay, some input is getting, the processing has been done to given to the next layer, and then the processing has been done here and given to the next layer, and then finally given to the output layer. That's how the processing will go. This one step from input to the output, getting the output, is called as forward propagation. So it is a process of passing data through a neural network to produce an output. Okay, so this is forward. It will go through one side, from input to the hidden layers to the output. And we have something known as loss function. Remember, we have seen it here. We have discussed about the loss function, which is the supporting we have to see about loss function and optimizer. They are inter together. So let us see about what is a loss function. So a loss function is a mathematical function that measures the difference between the predicted output of a machine learning model and the actual output. For example, you are having a forward propagation. You are giving your input data, it is passed into it, and it is given to the, like, it will give you the output. Some output value has been given, and it will compare with the original y value. What is the predicted value? It has the data, right? So what it will do is it will try to compare, and the difference between them is the loss. If the loss is 0, which means if it's 100% correct, then it is good. But sometimes you may have getting some lag, right? Some kind of loss has been predicted wrong. So if it is completely wrong, the value will be 1. So your objective is to reduce the loss function. So the loss function will help you to understand or measure the loss, which is what is the difference between the original and the predicted one. So this is where the neural network is going to be a king compared with machine learning. So what this neural network will do is, every time a forward propagation happens, the output will be given, right? Once you get the output, it will compare with the original output, and if there is any loss, what it will do is it will go for back propagation. So here comes the other term, which is called as back propagation. Based on the loss you are getting, if it is terrible, it will go for back propagation. So what will do is it will try to update everything so that when it run once again through the forward propagation, the loss function is reducing. Okay, the idea behind it is to reduce the loss function. It will go back and reassign some weight, bias, etc. so that the output can be improved further. So the weight and bias are adjusted based on the error between the predicted output and actual output, which is the loss function. Based on the loss function, the weight and bias are adjusted, which means it is going to reassign the value on its own. You are not going to add any weight or bias on your own. These values are done automatically by it. And how it's doing? First, it will go with the base value, and then it will go and check the output. If it is not good, it is going back for back propagation, and it works by back propagating the error backwards through the network at the output layer and working backwards towards the input layer. So it will start from the output layer, going through the input, like hidden layers, and to the input layer, and then once again the forward propagation will happen. The output will be getting, loss function will be calculated. Once again it will go back to update the weight so that it can improve on its own. That's what this neural network is. Okay, and how these weights are adjusted. Okay, how these weights are adjusted. So for adjusting the weight, okay, so you need to adjust the weight. Weight is nothing but the value we are adding here, right? We are adding weight, bias, and these extra values which will determine which value you are giving, how much it is passing from one to other. It will be happening in everywhere. Okay, activation function we will discuss. It is a function, it will get some input, give you some output, and we have some activation function. We'll discuss about that later. But focusing on weight and bias, bias is a constant, weight is a value assigned by it for the importance of each. And what will happen is, how these weights are adjusted, we are having something known as optimizers. Okay, so which are algorithms that are used to adjust the weight and bias in a neural network. So we are telling through back propagation the weights are adjusted. How it is adjusted? It is adjusted with the help of optimizer. For example, here also we have seen the term optimizers. Okay, now you can read this line and it will make sense now. A typical artificial neural network consists of a input layer and hidden layers, and finally output layer supported by activation function, loss function for calculating the loss, and optimizers for updating the weight. Okay, and moving through how weights are adjusted, optimizers are used to adjust the weight in a neural network with the goal of minimizing the loss function. The loss should be minimized. The weight and bias are updated via chain rule of differentiation. This is the base max you would have learned in school. Chain rule. Remember, optimizers use a hyperparameter known as learning rate. Okay, they have something known as learning rate that is used to control the step size during optimization. So that learning rate will help you to adjust this, and it is adjusted via chain rule of differentiation. And the ultimate goal of an optimizer in deep learning is to minimize the loss function and achieve the best possible performance on the task at hand. And one example here, we have other optimizers. One example of optimizer is gradient descent optimizer. Remember gradient descent. So this is a gradient, and what will happen is, imagine this is your global minima, which means this is the best or minimal loss value. Okay, you want to achieve this point, and your error, you are getting a loss of here. Okay, but you should get here. This is the difference between your predicted and the original. This could be the best minimum cost. Okay, so it cannot go zigzag here and there. So what this optimizer will do is, it will adjust the learning rate in such a way that this point will gradually descend from this, like you are descending from a mountain. It will try to come gradually so that it can reach the minimal value, or from here, if the value is low or high, it will try to minimize it in such a way that it can reach the global minima. And if you don't go with like the gradual descent, you may go, if for example this optimizer, if it assigning random values, what will happen is, one time it will be here, one time it will be here, then go here. So the value it won't be constant. So if you want to reach the global minima, it should adjust the weight in such a way that this will reach step by step, by incremental step, so that it can reach the global minima. And once again, how it is, like this is the task to achieve, but how the values are changed, it is achieved through chain rule of differentiation. So you have rho L by 2 rho Z. If you have that, if you go for back propagation, this value can be achieved with, if you calculate the sum of these two, you can get that. Okay, for example, see here how this is achieved. Rho L by rho Y equal to rho L by rho Z multiplied by rho Z by rho Y. You know these two values. Okay, rho Z and rho Z will be get cancelled, and this will be your output. So some back propagation and chain rule of differentiation is done so that the weights can get changed. And to sum up everything, let us go and see a recap, an overall recap, to don't get lost or confused in between. What is forward propagation? You give the input, okay, to a neural network, you give the input, and the neurons will add a weight for it. A bias is added, okay, and then it is passed through a activation function, which will give you the output. And now what is a back propagation? When you get the output, with that output, a loss function is calculated, how well it is good or bad from the function, whether it is changed drastically, how far it is from the output, whether they are same, okay, what is the difference between the original and the predicted one. And the loss is calculated. So with the loss, this optimizer will come into play to adjust the weight and bias. And how the weight and bias are added, it is done through chain rule of differentiation and back propagation. Finally, once this is done, it will update in a step so that it will go back and back to the input. So it will go to the input layer, and now the input layer have new weights assigned. It will go and start the step once again for forward propagation. Once again, the forward propagation will change the weight and bias, give the output, and then it will go front and back to improve the output. And if you are ready, we can start with the different types of activation functions. So to starting with activation function is an important thing. So whatever you are talking, okay, this function is doing something, this guy only giving the output. Imagine you are having an input, okay, some weight is added. For example, if you have 5 here, and here you have 0.1 as a weight. Now if you multiply it, you will be having 0.5, and what will happen is, some bias is added. Imagine 1 is added, so you will be getting some mathematical values from all the places. So you are taking it and giving it to an activation function. So this guy is doing something and giving you the output. And what is he doing, how it is happening? To talk about activation function, we have many activation functions. So based on the task you are doing, you have to select the activation function. Okay, based on what you are doing, you have to select the activation function. For example, we have many activation functions like sigmoid, tanh, ReLU, leaky ReLU, softmax, and linear. So based on which problem you are going to solve, you have to select these. Let us understand the math behind one by one, and let us see when to select which activation function. Starting with sigmoid activation function. So sigmoid curve. Remember when we talk about logistic regression, where we have a S-shaped curve. Okay, so the value ranges between 0 to 1 in a way that if you will be having a threshold value, if the value is greater than 0.5, you can give it as 1, and if it is less than 0.5, you can give it as 0. And this is a calculation or the math behind it, 1 by 1 plus e power minus z. Okay, the function z you are giving. Okay, this is a function. sigmoid will do what it will do. It will, if you give z, it will be given 1 divided by 1 plus the exponential of that value you are passing, and this value will be plotted in such a way that these points will be ranging between 0 to 1. Okay, so if it is above 1, it will, like above 0.5, it will be declaring the output as 1. If it is below 0.5, it will be declaring the output as 0. So this is what is happening here. The activation function, this is a sigmoid activation function. Okay, the output will be 1 or 0 in sigmoid. And the thing is, we have some disadvantage in sigmoid activation function, and there is certain place you have to go with sigmoid, and in some places you don't want to go with sigmoid. Why? Because in sigmoid activation function we have a problem which is known as vanishing gradient problem. Remember the term gradient descent optimizer, we have seen, right? Achieving the global minima. And where it comes into play, when you go for back propagation, you want to achieve the minimal loss, right? But we have a problem with sigmoid where there is something known as vanishing gradient problem. So what will happen is, see here, you are ranging it between 0 to 1, fine. But when you go for back propagation, what will happen is this function will be again used. But when you go for back propagation, when you take the derivative of this sigmoid function is going to range between 0 to 0.25. Up to this range, when you take the derivative of these values using sigmoid, your values will be ranging from 0 and a maximum value of 0.25, not above that. Okay, we are getting this. But what is the thing is, when you get a range between 0 to 0.25, then it is a very small values. So when you go and adjust using optimizer, this value will be like hardly will change. Okay, the change will be between 0 to 0.25. So it is not going to update it that much, so that this point will be stagnant here itself. So it won't be able to achieve the global minima. Okay, this is what known as vanishing gradient problem, because the derivative value is from 0 to 0.25 and you cannot update it more than that. Okay, and then to avoid this, you have something known as tan h function if you want to use. So this tan h will perform this formula where exponential of z minus exponential of minus z and divided by this. Okay, so what you will be getting is, it will range, the value will range between 1 to minus 1, and you can have the threshold as 0. But the thing is, to avoid vanishing gradient, here the derivative will be from 0 to 1. It is not from 0 to 2.25. Here it will be 0 to 1, so that if you go and take the gradient, it will be descending and you won't be having any kind of vanishing gradient problem. And we have another functions, these are important, we'll be using, this is called as ReLU function. So if you have activation function as ReLU, okay, then what will happen is, it will take a maximum value with a comparison of 0, x. X will be your input value. If the input you are passing is a positive value, then 0, the positive value which you are passing will be the biggest value. So the maximum value among this is the input you are passing, so that will be taken. Okay, but when you have a negative value, now who is the biggest one? Who is the max? 0 is the maximum, right? So the max value 0 is taken. So the negative values have been neglected in this ReLU, only positive values will be taken into account. That's what this will do. This will just remove the negative and give whichever greater than 0. Maximum of the value. 0, x, who is maximum, it will give you as the output. Okay. And then when you go for leaky ReLU function, so in the thing is, in ReLU function you can see, right, so when you go for ReLU, the negative values are neglected here, and this is kind of a issue. So what will happen is, for leaky ReLU, what they have done is, instead of 0, they are multiplying the x with 0.1 and then comparing, okay, with x. So whoever is the biggest one, so if you have negative value, they will be descending in a, like, they have very lowest values. They are not neglected completely, but less weightage is given. And if you have a maximum value, if you have another value which is x, okay, which is positive, then it will be taken into account. That will be your maximum value. That's what a leaky ReLU will do. Something is leaked here, so that's what the name has been given as leaky ReLU. And then softmax, this is also important in many cases for multi-class classification. We'll discuss when to use which function. Softmax function. So you'll be having the input, the output, like the output will be given, right? So this output is passing through activation function, where softmax will give you the probabilities of each, who is the most probable. So from that you can find which is the probable. Here this point 5.1 is the most probable. So likewise it will give you the probability. Based on that you can select. For example, this is used in multi-class classification. You have 5-6 classes and you are passing it to softmax activation. Who is most probable, you can get and give it that as an output. Okay. And finally we have linear activation. So this linear activation function, also known as no activation or identity activation. So it is doing nothing, guys. So in where the activation is proportional to the input and the function does not do anything to weighted sum of the input. It simply gives the value it was given. Okay, it's so the next thing is how to select the activation function. When you build a neural network, you have to go and call the neural network. You will be assigning the layers. It is up to you. Okay, so in case, how will you going to add this activation function? Which are you going to select? You will be building the neural network using some libraries. We will discuss that. So in case of binary classification problem, okay, either 0 or 1, yes or no, ReLU and ReLU is hidden layer and sigmoid function is chosen in the output layer. Why? ReLU and ReLU are chosen in the hidden layer. So in between the hidden layers, ReLU and ReLU is chosen. And when you go for output layer, since it's a classification and binary classification, sigmoid function is taken into account. Okay, sigmoid function, what it will do, it will give you 0 or 1, right? So that threshold value is required in this output layer. But since it's a binary classification, we need it in the output layer only. When you go for multi-class classification problem, we use ReLU, ReLU in the hidden layers and finally softmax layer in the output. Why softmax? Because multi-class, we need to find who is most probable. So softmax is used in multi-class classification problem, and in case of regression, we use linear activation function. Once again, is it clear regarding how to select the activation function? In case of binary classification problem, ReLU is chosen and ReLU it's optional in the hidden layers. But in the output layer, you have to go with sigmoid function because the output you want is either 0 or 1 and it can be obtained with sigmoid function. In case of multi-class classification problem like multi-class, you will be using the same ReLU and ReLU in the hidden layers, but softmax in the output layer because you want to get the most probable one. Okay, and in case of regression problem, we choose linear activation function. And if it is clear, our next step is go and learn about the loss function. So remember the loss function, he is the guy who is going to tell you whether the output you got is good or not. Here, the loss function, he is going to calculate and give you some feedback so that it can be given to the optimizer to adjust the weight. And there are different type of loss functions are available like MSE, MAE, binary cross entropy and categorical cross entropy. So based on the task you are going to do, you have to give it correctly. Okay, these things are important when you are building a neural network. You will understand it there. So I'll go and tell you about when to use MSE, MAE. So mean square error, mean absolute error, you know that these are some of the tasks which you will be using for the metrics, right, for regression problem. So the same thing, when you go for a regression problem, you can use this MSE or MAE for calculating it. And we have binary cross entropy. So the name itself suggesting binary, and this binary cross entropy is for calculating the efficiency of it using for the binary classification problem, 0 or 1, yes or no kind of problems, binary cross entropy. And you have categorical cross entropy. So what is this categorical cross entropy? This is for multi-class classification problem. Okay, when you have multi-classes, you will be having multi-class classification. You can go with categorical cross entropy. And before going into the next one, let us see a recap of when to use which one. Okay, once again, if you have a binary classification problem, you will be going with the activation function like ReLU and ReLU in the hidden layers, and in the output layer you will be having sigmoid, and the loss function you will be using is binary cross entropy because it's a binary problem. When you have multi-class classification, same ReLU and ReLU is used in the hidden layer, and in output layer we have sigmoid, and the loss you are going to use is categorical cross entropy. Finally, if you have regression problem, you will be going with linear activation function, and MAE, MSE is used for the efficacy for loss function and its calculation. And then going with the optimizers finally. Okay, optimizer is the guy who is going to update it, and he has something known as learning rate. He is the guy who is responsible for changing the weight. Okay, and he must do it properly so that you can get good output. So when you go and talk about optimizers, we have two things. One is known as gradient descent, another one is Adam optimizer. And recent times Adam optimizer is the best, and in most cases Adam optimizer is used. And we'll be mentioning everything, guys. When you create a neural network, you have to manually give it everything from taking it from libraries. And regarding gradient descent, we know that what will be a gradient descent will be doing. It will update the weight in such a way that it will go in an incremental step and reach the global minima, so that the loss is completely zero, the best loss value loss function. And how it is done? It is done by adding a learning rate, some values added so that it can be improved. Then the next one is Adam optimizer. So when you talk about Adam optimizer, recently it is one of the best one. So the thing is, what will happen in this Adam optimizer is, we are having something known as learning rate, right? So it is constant and all here, but when you go for this Adam optimizer, based on the output you are getting, Adam optimizer, the learning rate is also improved in Adam optimizer. The learning rate, weight, bias is also added, and it is done by taking exponential average. Okay, from when it moves, it will take and consider for the next one also and take an average. So that's what known as a moving average, and exponential average, moving average is taken so that it will be achieve this global minima. Okay, by updating the learning rate also, this one plays an important role. Adam optimizer will be using it in many places. And then these are all the introduction about deep learning, about neural networks. So to understand or create a base neural network, you need to know these kind of concepts. And where are you going to get all these activation function, neural networks, neurons, activation, like other things like loss function, optimizers, etc. It is available in these two libraries, TensorFlow and Keras. So TensorFlow has some part of Keras, and Keras you can go and take separately from itself also. Like you can use a combo, no issues. But these two are very important libraries. Like scikit-learn is for machine learning. TensorFlow and Keras are important for deep learning. So you can get all the neural networks from there, and you have to build it on your own. And so to start with, if you want, you can go and install using pip install Keras and pip install TensorFlow. And yeah guys, so the next thing, once you are installed it, you can build, like you want to understand what all the types of neural network is. You have artificial neural network, like we used to create for text data like CSV files. Instead of algorithm, you can do that by creating a neural network by creating many input layers, one input layer, many hidden layers, and one output layer, by adding activation function, etc. But the same activation functions and all are common for all the type of neural network. Okay, the term we have discussed today, activation function, optimizer, loss function, bias, weight, are common in all the three. But how are you going to differentiate this? This is for your normal CSV file data, so you can use this ANNs. Okay, but if you have image data and if you want to classify an image, then you can go for convolutional neural network, which is for images particularly for, and they play a best role. And if you have like sequential data like audio files or human language data like NLP data, you can go with RNN, which is called as recurrent neural network. And in the next class we'll be seeing about convolution neural network, how an image. Okay, when you talk about an image is nothing but the pixel values. The pixel value is nothing but numbers. So here also we have numbers, so we'll be taking this number and passing through multiple processing step, and then it is going to go into the same neural network. It is number, right? This neural network can handle numbers, and the output will be given. So how this is working, the math behind it, we'll be seeing that in next class. And with that, we are also cover dog versus cat identification project using CNN, and there we can build a base neural network, and you can see that. Wait for it in tomorrow's class. Thank you.